radical is a root. Okay, so we're going to be dealing with square roots. What do we know about square rooting?
You can't root a negative.
You can't root a negative. So the root of a positive number, that's good. Can you square root 0?
Yeah.
That's good. Square rooting a negative, however, is something that doesn't work. Okay, square rooting a negative number. Okay, so I have to look at this x, thinking about what I want it to be, what I don't want it to be. So something like 10. Would 10 work for x? 10 subtract 7 is root 3. Does root 3, is that possible? Yeah. Does 7 work? 7 subtract 7 is 0. Can I square root 0? Yeah. What about 5? Would 5 work for x? 5 subtract 7 is negative 2. Can I square root that? Can't square root that. So x is not allowed to be less than 7. Okay, so you need to think about what makes it 0, and then think about the one side of it and the other side of it. Okay, so what makes this 0? Negative 5, right? So we're going to go bigger, and we're going to go less and think, okay, which side works? So if you're greater than negative 5, think about a number that's greater than negative 5. 10. Think about something that's less than negative 5. Negative 20. Okay, so which works? 10. 10 plus 5 is 15. Can I square root that? Yeah. Can I square root it if it is exactly negative 5? Yeah, because then that's root 0. If it's something less than negative 5, for example, negative 20, does that work? No. So I don't want x to be less than negative 5. Okay, what makes this 0 if x was 0? So if I go greater or less than, okay, what's something greater than it? Maybe I should have put this on a number line. Greater is like a 10, a less is like a negative 3. Which side works, which side doesn't work? We could square root if we're bigger than 0, if we're equal to 0, but we can't square root less than 0. So what don't I want? I don't ever want x to be less than 0, or else it's just not going to work. Okay, what makes this 0 if x was 8, right? Because 8 subtract 8 creates a 0. If you're greater than 8, like 10, if you're less than 8, that's like a 6 or something. Anything greater than, anything less than. Which side works, which side doesn't work? Okay, so if it's greater than, for example, 10, 8 subtract 10 is negative 2, and now I can't square root that. So that's not going to work. If you're less than, for example, 6, 8 subtract 6 is 2, I can square root that. So that's going to work. That's going to work. So I do not want what? I don't want it to be, I don't want x to be greater than 8, because then it's not going to work. Okay, but that's the whole idea there. You can't square root negatives, so you're trying to think about what x numbers will make that negative. Okay, adding and subtracting radicals. So this is like terms. So if I ever had an equation with some x's, you can put them with other x's. If you had y's, you could put them with other y's. Those are called like terms. So this is a root 3 term, and this is a root 3 term. So I can put those together. How many root 3's do I have? I had 2 root 3's, and then I subtracted a root 3. So that leaves me with 1 root 3. And now I have a root 7 term and another root 7 term. So here I had 6 root 7's plus 2 root 7's. So I have 8 root 7's. Okay, number 2. Do you see anything that's similar that you could group together? So this has a root 5 in it, and this has a root 5 in it. So how many root 5's do I have altogether? 4 plus 3 is 7 of them. Then I have this term that has a root 7, and this term has a root 7. So 10 root 7's, subtract 2 root 7's, makes 8 root 7's. And then a plus 4, because it doesn't go with anything. Okay, multiplying. So when I multiply the radical of 11 times the radical of 3, I get the radical of 33. Okay, number 2. So do you see on these, I have some numbers that are the whole number outside, the coefficients, and some numbers that are radical. They have to keep kind of separated in your brain. So the whole number 2 times the whole number 4 makes whole number 8. And the radical, so the coefficient part is separate from the radical part. The radical of 3 times the radical of 6 makes root 18. Okay, so number 3. Whole number is going to be a 5, right? Because there's a 5 on this, there's a 1 on that. And the root is a root 7 and a root 8, which makes root 56. Okay, number 4. What's the whole number? So there's a 3 and a 2. Okay, so out front, my coefficient should be 6. Root 10 times a root 10 makes root 100. Which, sorry, what am I looking at here? This? What happened to the, sorry, I can't hear.
What happened to the 4? I didn't write.
The 4? You just need to have plus 4. Because you can't put it together with anything. It's like trying to smush an apple and an orange together. Like, you can't collect it with anything that's like it. Okay, so this example I'm not done. Does anybody see anything I could maybe just go further with on that? Do you know what the root of 100 is? It is 10. Okay, that's not a root 10, right? It gets rid of the root. The root of 100 is the whole number 10. Now this is a whole number times another whole number, which makes 60. Okay, breaking down roots. So I need you to think about all of your radical numbers. You're going to have them pretty familiar in your brain. So how do you ever get a 1 is root 1. 2 is because you do a root of 4. What's your next perfect square number? Root 9. Keep going. See if you can go all the way to 12, I challenged you. Okay, this is 16, 25, 36, 49, 64, 81, 100. Did anybody get that without their calculator? 121. And 12 is 144. Okay. So breaking down roots, we did this a little bit in grade 10. So I'm going to ask you here, root 32. What's the largest number you can divide it from? Can you divide it by 36? No. 32, can you divide it by 25? No. 32, can you divide it by 16? Yes. Okay, so root 32 is the same as root 16 times root 2. Because if I started like that, you would times those together to be root 32. Okay, what is root 16? Whole number 4 and then a root 2. Okay, so this is called an entire radical and this is called a mixed because you have a whole number component and a radical component. Okay, 300. Can you think of any of these perfect square numbers that you can divide 300 by? And you always try to find the largest one. So for example, 300 is divisible by 25, but there's actually a bigger one. 100. It's divisible by 100, right? So 100 times what? 3. So root 100 times root 3. That's how I get a root 300. Do you see a root 300 out of that? Then root 100 is 10. So 10 root 3. Okay, 20. What kind of magic number is 20 divisible by? So I'm looking at these numbers. 20 is divisible by 4. So I'm going to go root 4 times root 5. That's how I get a root 20. Okay, but this time we had a coefficient number. So I also have to remember to bring that along for the ride. Okay, so what am I breaking down? Root 4 can change to a whole number 2. This was a whole number 6, and this is a root 5. So now I can put this whole number together with that whole number, making 12 root 5. Okay, so we'll try one more like that. Root 75. So you have to look through your magic numbers. 75 is divisible by 25, right? 25 times 3. That's root 75. Okay, whole number 2 needs to come along. Now the root 25 is going to change. So that's going to change into the whole number 5. I had a whole number 2 and I have a radical 3. And now the whole number parts can be multiplied together. So 10 root 3. Okay, let's put this all together. Let's do one of these, I guess, and we'll save one for next time as a recap. Okay, let's do this last one. It looks a little harder, maybe. Okay, so root 27. That's where I'm going first. 27 is divisible by what magic number? 9. 9 times 3 is 27. So the root 9 times the root 3 is root 27. Okay, root 9 turns into the whole number 3. Whole number 2 is on the front, root 3 is in the back. So now this makes 6 root 3. Okay, root 20. Which magic number is root 20 divisible by? So that would be root 4 times root 5 plus the whole number 5 is in the front. The root 4 can change to a 2. So I end up with plus 10 root 5. Okay, 12. What magic number is 12 divisible by? So it's divisible by 4. So root 4, root 3. So the root 4 changes into the whole number 2, so 2 root 3. Okay, root 500. 500 is going to be which magic number? Can you think of one of the magic numbers that 500 can divide by? 500 is divisible by 100. So root 100, root 5. That's how you make root 500. What's that? 100 times 5 is 500. Yeah. I have to, when I divide it, I have to pick one of these numbers better be one of the magic numbers that we just talked about. You know what I mean with magic numbers that I keep saying? 16, 25, 36, 49. Those are all like the magic numbers we're trying to look for. Something that we can square root. Do you know what I mean? Like, for instance, like this you could write, if you were writing 50 times 10, yeah, that's 500, but can you square root of 50? No. Can you square root of 10? No. So we're trying to aim for two multipliers, with one of them being one of our magic square roots. Yeah. Okay, so the root 100 is going to turn into a 10, which will be 20 root 5. And what do you want to do with this? What is root 4? Root 4 is the whole number 2. So that would turn into a minus 4. Now there's no radicals on that because the radical part all broke down. Okay, I'm not done. This is not my final answer. Is there anything like each other that I could group together? 6 root 3's subtract 2 root 3's means I end up with 4 root 3. Ten root 5's plus 20 root 5's means I end up with 30 root 5. And I have to put subtract 4 as well because it just doesn't go with anything, so I can't group it together. It's on its own.